Good afternoon, everyone. I'm Jim Lake, head of training here at Viking. I got James Golinveaux today. We're going to talk about new technology and equivalency, and it's a big subject. I know it's another one of your favorites, but it's the history of the new technology that we'll talk a little bit about, but it's also mostly combining it with kind of how the standard NFPA 13 has actually responded to it. And so, I also know that you like to get comfortable when you talk about things. I know how to tee up these subjects for you. I've known you for a long time, so I figured maybe we'd start off down the pub, and now that'll just make things really comfortable for all of us, I think. So,
the captain diet single salt.
There you go. We got the order. But what I thought we'd do is we'd follow along a timeline, really, and this isn't really a timeline of the new technology itself or when it was being researched. It's actually when it showed up in NFPA 13. So a lot of this was going on when you take a look at extended coverage or quick response or residential. A lot of that research and even the use of the technology was well before it ever got defined in NFPA 13, which I thought was kind of neat. It's like, okay, new technology isn't a new thing. We've been doing this forever.
You could back it up all the way to 1953 when the spray sprinkler came around. It was a new technology compared to the conventional or the old style. So we've had different stages of new technology that have gone through. More so after the 83 when we had a new technology exception in NFPA 13. But some of these other advancements came around well before the 83.
And we're living with some. I mean, really, these new advancements, that you're talking about, extended coverage, quick response, residential, that's all fed into, this is new technologies that we're still applying to specific sprinklers now, whether it's the attic sprinkler, the coin sprinkler, the ESFRs or things. These are things that have stuck and they're really in the standard now, but also they're part of the basis of everything we designed.
Right, and many of those went through a more traditional testing, research foundation, and or a manufacturer doing specific testing, but then going through the standard process in NFPA 13, where you submit fire test data for all the information for the full 13 technical committee to review it. A little bit different than the technology exceptions that we have there, the new technology equivalency standards that we have out there today.
Cool. So let's take a look at some of these then. The first one that really kind of drove everything or at least changed after we started with spray sprinklers, then they started into the late 60s and into the 70s, extending the coverage. I mean, just changing. So what were we changing here then to extend the coverage? What was the big challenges here, or what were we trying to accomplish?
Well, buildings weren't complying with our standard.
Oh, well, all right, so let's change that.
So, you had extended coverage. One of the first mindsets we had was in light hazard and also in sidewalls, sidewall applications. And room configurations of high rises just weren't conducive to having the bathroom wall, and then where the curtain wall is or the window wall was further than the standard distance of a standard sidewall. And for light hazard, it used to be 15 feet, and that was as far as you could throw. These rooms were 20, 24 feet. And we were constantly have to build soffits or to get the pipe out into the room. But the advantage to make an extended coverage sidewall was obvious, so we didn't have to build all the soffits. So there was a need. And that went through the first part of extended coverage went through the more traditional because it was limited to light hazard. The committee quickly put boundaries on it. They said when the first extended coverage came out, they went up to the 20 by 20, went up to the 400 square feet. And then Central Sprinkler introduced the 22 by 22.
Right, I remember that one.
And now everyone had somehow they had an epiphany of their fire protection knowledge and said, no, we'll never go above 400 square feet. That rule still exists today for no good reason.
Well, for these.
For extended coverage, for light hazard, and for the extra hazard, it's 196 square feet. Because people were, they're afraid of the technology and how far do you let it go beyond the standard spray sprinkler. But you really have to understand the limitations of a standard spray sprinkler. It was developed in 1953. And God bless, Factory Mutual developed the spray sprinkler N53, but it's not the perfect sprinkler for every application.
No.
And when we talk about extended coverage in light hazard, and we talk about what came about from that, the residential and some of the distribution pattern and the higher wall wets, we'll talk about that.
Right, and that's why we start with this, because this kind of drove a couple of other major changes in that, in the 70s.
And when I first came into the research and development, it was the extended coverage ordinary hazard. And everyone said, oh, you're going to go up to 16 by 16, or you're going to go up to 20 by 20. And it's not going to be as good as fire protection. They're further apart. They're more subject to obstructions, and they're going to be less sensitive because of their distance from the fire. And it was to the contrary. We proved that it was better fire protection.
Oh, wow.
Especially with limited clearance, especially with 18 inches. And as a young person coming into the research and development, it was amazing to find out where some of these legacy rules came from. Where did 18 inches commodity clearance come from? It's ingrained in your head.
Sure.
When you read the book, it's 18 inches, it's 18 inches. And then you go do some fire testing with standard spray sprinklers, and you find out, oh, they're not really designed for 18 inches. And we weren't burning a whole bunch of buildings down, but when we did the extended coverage ordinary hazard, we were able to prove better fire protection. Bigger drops, further spacing, the sensitivity changed because of the response. We'll talk about that today. But you combine a couple of technologies together, and maybe we never should have had a standard spray sprinkler in some of those applications. So some of these new technologies, they're pegged as new technology. They're just better fire protection for the occupancy that you're protecting.
Yeah. So the idea here then is that once that took hold, it's fully, like, as you said, it's fully ingrained in the technology now and in the standard.
Right.
It's defined in the standard, it's fully ingrained. And that kind of led to, or as you just said, it combined in with this development. In fact, they kind of overlapped in time, early 70s again to the late 60s, early 70s. People were messing around with this quick response concept, and I'm imagining it was because they were also looking at this extended coverage and how do we get it to respond in the same way. So
in the 70s, you got a couple of things going on. You have the sensitivity to the spacing, and you also have the development of residential coming in.
Right.
So that was starting to do some of the research, and they needed a faster response.
Right.
The ironic thing about it is when quick response was coming out, it was limited to residential, light hazard, and some ordinary hazard. But God, please don't use it in extra hazard or storage occupancies.
Right.
Because that was protected territory. And it's amazing today with the ESFR and some of the other technologies that they all use quick response for the protection of those occupancies. We just do it smarter. The standard response sprinkler, for those of you who know UL 199 or the FM standard for standard response, the sensitivity time frame to a fire can be pretty broad. You can explain it in a plunge tunnel, but you can have something that can go from 28 seconds to 3.5 minutes in a plunge tunnel and still qualify as standard response.
Right.
So when you have that, you have a standard written around standard response. Quick response was sort of voodoo at first because it was being applied to the same area density curves as the standard response sprinklers were being applied.
Okay.
And people were afraid of quick response because we'd open up too many too soon.
Right.
And we have learned that quick response is really the technology at hand. Most new technologies are using quick response as a standard base. It's better to be on the fire early if you have a smarter application of water.
Right.
So although it started for the spacing to make it equivalent to a standard sprinkler at normal spacing. When you start spacing it further apart, using quick response will give you the same sensitivity of a slower sprinkler at standard spacing. But then you get the enhancement of earlier on the fire, and we've been using that benefit since then.
Yeah, and as a matter of fact, the standard flipped. Closed the door on standard response and light hazard altogether in the late 90s, early 2000s, somewhere in there.
If you've got people involved in an occupancy, you should be using quick response sprinklers.
Yeah.
You want to be as fast as you can be. Now, I'll argue on temperature.
Okay.
I think we've made a mistake on the 155.
Why is that? Well, if you,
I think 155 was a great reason 50 years ago that we should be using 155s in occupancies because of the response time of a standard spray sprinkler. You need to lower the temperature down as much as you can.
Sure.
If you have a slow device. Having the faster devices with the 100-degree ambient temperature, we get a lot of questions, as a manufacturer as to, how did you ship the box? Where was it stored? Was it in the back of a truck? Did it ever see above 100 degrees?
Okay, so
we get a lot of questions about
right.
the 155, where the 200s and the plunge tunnel and the sensitivity is not that far off from a 155 as far as time. And it has a lot more safety factor relative to the ambient temperature to which it's installed.
Right.
And I believe a better control device. So I've become more of a fan of the intermediate temperature of the quick response because the 155 followed the legacy of the standard response 50 years ago.
Okay.
And we're just ingrained, just like that 18 inches. We're ingrained to this 155 just because that's our standard. It doesn't have to be.
Well, there's a lot of that doesn't have to be, I guess. So right now it's fully ingrained, as we said, quick response, fully ingrained into the standard. As a matter of fact, as I said, they've closed the door on it in light hazard. You can't, I'm sorry, they closed the door on standard response in light hazard. So
because there's no issues of using quick response when it's relative to people or occupants.
Right. So along in that 70s came the America Burning Report earlier, and a realization we've got a real challenge with people dying in residential fires, residential occupancies. And we began to see also the combination of this extended coverage and the quick response into a new type of a sprinkler that was actually being designed to be put into residential occupancies. We got a couple of videos on the spray pattern combination there, but this is kind of our 4 of our big sprinklers anyway, our residential sprinklers. One of them's even a newer look now than before, which is the residential upright, which is kind of neat that, that wasn't something in the original designs, was it? There wasn't any residential.
There wasn't a need originally because we weren't sprinkling the basements. We weren't sprinkling a number of areas that didn't have a finished ceiling or an occupied area. But now we get a lot of equivalencies where they want the basement sprinkler, or they want areas where an upright is only possible to have a sprinkler system. So an upright starts to make sense. But it's interesting on residential technology as you look at the series of sprinklers here. And you go back to the LA fire tests or the San Francisco fire tests that developed the residential technology. And the smartest minds in the industry started with a standard spray sprinkler.
Again,
it wasn't a magic day that, hey, I have a residential sprinkler, let's go do some fire testing. They were doing fire testing with standard spray sprinklers and not getting the results they wanted with the curtains and the combustible wall panels. So it became obvious during that fire testing that they needed higher, flatter wall wetting distribution. Keep the water higher, prevent flashover, temperature control, and the getting people out of the room. So it wasn't magic that the standard spray sprinkler again was the magic answer to everything, but it was what they started with.
So they start with that. How do we change it? And a couple of interesting videos here. This was a standard spray sprinkler. It's out in our flow lab here, and it is literally 6 feet from the wall. And you can see that if we look 6 feet to 28 inches down, that's that magic number for the residential sprinkler as far as wall wetting is concerned. You can see that that the standard spray it's doing what it does, but it's nowhere near the 28-inch mark. Even at its 12 by 12 spacing, it's not.
It's designed to a laboratory standard at 8 feet out and 4 feet down, and that's where it has to throw water. It can't throw above it and can't throw below it too much. So it's a regulated minimum for a standard spray sprinkler, and that's why it's so confined.
And then this comes along. We go to the residential, and you can see obviously now we've modified the spray pattern. You got a much higher wall wetting characteristic going on here just for that purpose, because the fuel loads out there on the perimeter, plus the walls are absorbing. One of the ways you avoid flashover is to kind of keep those walls wet so they're not reflecting the heat back in. But that's where we slight modifications. And again, what was fascinating to me was all this was happening in the 70s, and it really wasn't until about almost 1980 when it was defined. The residential sprinkler was actually defined in NFPA 13. While all this was going on, nobody was defining it, but there was stuff going on with the new technology the terminology that was
and
in
the
there.
number of heads to calculate
Right.
and the performance, and a lot of that came from the LA fire test and the stuff
Right.
that they were doing in San Francisco. And the hard part about making this distribution pattern work is getting 28-inch wall wetting in the corners.
Yeah.
Sure. The residential sprinklers don't throw in a square pattern.
Right.
Unless it's a sidewall.
Okay, right.
But it's really difficult to get that 28 inches in the corner and still make everything work with the minimum flows.
Right.
We talk about, 0.05 density, and everyone, that came around late.
Oh, is that right?
It started off with a 0.1, and then it turned to a free-for-all on densities.
Okay.
There was no minimum density, it was the fire test. If you passed the fire test, you passed a residential fire. It got down to as 0.03, 0.032 density in some of the listings that were out on the street. And the NFPA stepped in the wisdom of NFPA and said, oh, we don't like them that low, we want a 0.05 density. And everyone felt really good about, okay, at least we have a number. It's 0.05. It wasn't scientific, it wasn't based on anything. But if you actually look at the distribution of a residential sprinkler out on the middle of the floor, the minimum pan collection is 0.02.
It is, and then we're also collecting water on the walls too, right? I mean, a lot of that water goes to the walls.
If you look at the distribution of a residential sprinkler, the majority of the water is going to hit the wall. Because that's where the committee had decided. So that 28 inches, is that the correct number? It's what the LA fire test and the first Grinnell prototype ever produced.
Okay.
So that's what the fingerprint was. So 28 inches was what residential was based on. Could it be 36? Could it be 22?
Sure.
Is there another number out there? It takes a lot of testing, a lot of effort to change that number, but is there value in it right now? They're so economical at a 0.05 that no one's really pushing the button saying, we need a new technology to go to 0.04 or 0.03.
Right.
But it can be done.
So, as we said before, with the other sprinklers, they're fully ingrained. You can use it in an NFPA 13 system, certainly 13D and 13R, but it's recognized by all, and it is totally ingrained into the standard and into the designs. So this is where I want to pivot now to the language that was in the standard. And so you got all these things going on in the early 70s or the mid 70s, and there's this statement in 1970 that actually didn't come in until the early 70s, this purpose statement. And the purpose of the standard, and a lot of people, anytime you kind of go through this, it's standard language. The purpose of the standard is to provide a reasonable degree of protection and all of that goes along with it. But it doesn't really say anything. The standard endeavors to continue the excellent record. Well, that's brilliant, but it doesn't tell me how it's actually going to do that. It has been established standard sprinkler systems and meet the needs of the changing technology. So again, that's that purpose statement. But then we started adding to the purpose statement. We started adding a couple of paragraphs in the 70s, and maybe you can give us a little bit of background as to nothing in this standard is intended to restrict new technologies. Well, okay, that's a great statement to live by, or alternate arrangements. But why suddenly were we talking about? Was it these three things that were coming along, or was it something else maybe driving a need for these statements to be increased?
This particular statement was an addition by the technical committee. So some things come in from the public, some things come in from the technical committee.
Okay.
I was mentored by Chet Shermer and Rolf Jensen when I first came on to the NFPA 13 technical committee. And Chet saw that I had a passion for the innovation and the new products. So he put me under the guidance of Rolf Jensen.
Oh, wow.
And said,
big names.
Rolf wrote this in 1983 for the technical committee.
Okay.
So this was a submittal by Rolf Jensen
Mhm.
that went under the name of the Technical Committee on
Okay.
Automatic Sprinklers.
Uh-huh.
And Rolf was the chair of the New Technology Task Group at the time.
Okay.
So when I came on in 91, I wasn't a member, became a member in 94, but I was participating on the NFPA 13 in 91, and
Mhm.
Chet quickly put me under Rolf and said, you belong with him.
Yeah.
But the story that I had heard was Rolf was working on a couple of projects. I think the Palmer House, which was a hotel in Chicago,
Yeah.
had some specialty needs of different applications of sprinklers.
Mhm.
And as a fire protection engineer and as somebody very knowledgeable about most of the NFPA 13 standard, he didn't have anything in the standard that gave him a right to practice his trade or use that equivalency.
Yeah.
To say, yeah, I know what the current products do.
Mhm.
I know what the standard says about them, but this building doesn't meet that application.
It's a prescriptive code. I mean, it was, that's the
And
reason.
it's based on the data that had been submitted in the past or the evidence in the past, and the new technologies of buildings were changing, and he needed something as a hook to go in and say, I have the right to do this, but I
Mhm.
don't want to lower the level of safety.
Right.
But the prescriptive part of the standard can be met in other ways.
Yeah.
So that was his first step to bring it in.
Mhm.
And when he did, this was when Chip Schirmer was the chair, and he was and Rolf was the chair of the New Technology Task Group,
Mhm.
that Chet kind of gave him his free rein to say, okay, this is
Right.
your method to get new technologies into the standard.
Great. And
Faster, let me,
okay.
faster than the normal process of going out
Sure.
and doing a lot of testing,
Mhm.
a lot of research to the satisfaction of the full technical committee,
Mhm.
which may or may not happen in a timely manner.
Right, because the standard every 3 years, and new technology and
Right.
technological needs, they happen every day, as we know even now. I mean, we're constantly looking at different uses for the products that we have, the potential different uses for things. So we need to be able to have that freedom to.
NFPA issues every 3 years.
Mhm.
That's adopted by a model building code.
Right.
Which issues every 3 to 5 years.
Right.
So the model building code may adopt a previous edition of NFPA 13, and then your state building code, for
Mhm.
those of us in the United States,
Mhm.
will adopt a model building code of
Right.
the past.
Mhm.
So you could be 9 to 12 years behind
Right.
in your NFPA 13
Mhm.
based on your state building code. So to get something into 13, which takes time, may
Mhm.
take you 1 or 2 cycles, then to have that go through the adoption process, having something like this in all the editions since 1983,
Mhm.
everybody has this now.
Mhm.
So
Yeah.
every model building code, I don't
Right.
care if they reference the
96.
96 edition or the 94 edition, whichever they adopt,
Mhm.
has this equivalency statement
Sure.
in there, which gives the engineer of record a right to submit something of equivalency.
Right.
So it's a great statement to have in a product-related standard that we have out there in
Right.
NFPA 13.
And then it also added, so there was some additional guidance added too. I mean, you can't just go throwing things around here and saying, yeah, now I'm going to do it this way. There does need to be some limitations on, and more specific guidance, I guess, on how
Yeah.
these are to be installed.
This section came around later because people were saying, well, is it really the overall life safety? I'm just talking about a new pipe tube, or I'm just
Mhm.
talking about a thinner wall or another material of a hanger.
Yeah.
And that's where the materials or devices,
Mhm.
like, we're starting to be talked about.
Mhm.
Because there was a need to have newer technologies in those, but did it really affect the life safety?
Yeah.
Was
Okay.
it really the purpose of
Mhm.
you wanted it to work, you wanted it to be in accordance with its limitations in the listings,
Right.
but this gave the right to the thin wall tubes to come out and other pipe
Oh,
materials.
okay.
That's where people were talking about this, but it was hard to put that a thinner tube affected the life safety of the building
Sure.
or the intent of the NFPA 13 standard.
Okay. All right, so now I know this subject is near and dear to your heart, but it also came along as the new technologies the new technology statements were finding their way into the purpose and then divided out into these areas and building on top of the fast technology, the faster, the quick response technology and stuff. we began to see an evolution in the late 70s to storage protection, right?
Large drop being the first of them.
Large drop being that first. Now, I'm gonna tee this question up and I'm gonna let you go, and we'll see how long this takes, everyone. But take us from large drop to ESFR, because it was the first time, large drop's the first time we say, oh, we've got a challenge here that needs something different than the standard spray approach or extended coverage or anything. And then it goes all the way up to, well, that's not, as the industry continues to change, the storage industry, we begin to see, even these aren't, we need to continue to push this envelope, because they're continuing to push the envelope of their storage. We need to keep up with them with our technology. So I'm going to tee that one up and let you go with just a quick run through of these.
It's a fun story. So Factory Mutual developed the, in partnership with a couple of manufacturers, Viking had the first successful large drop sprinkler. It was a K11, but it wasn't referred to as a K11. It was referred to as a large drop. So if you look at the first NFPAs, it actually has a reference under the orifice. It says large drop. And that was the name of the sprinkler, and it's very specifically designed. If you notice, it's a standard response. This is one of the later versions of a large drop, because you had the glass bulb. The first one was a standard response link. And the large drop was developed, I believe it was 78, 76,
late 70s,
between 76 and 78, that the large drop was introduced, and it was for the higher fire challenge and produced larger water droplets. Great articles all over the industry about this larger producing droplet size sprinkler. And you got to consider the largest orifice size allowed by NFPA 231 and 231C at the time was a K8. That was the largest orifice size allowed. It was illegal, and no new technology exception in those. To use a K11 of any sort other than when this came around to be the large drop. So if you didn't use this, you had to use a K8 upright. And we now know all the limitations to the K8 upright with all the new fuel charges or challenges that are out there. So the large drop existed, and then in 1980, I believe it was 86, was the introduction of the ESFR. But it was interesting, again, if you do the historical, Factory Mutual developed the first ESFR, did the prototypes and used the manufacturers. I think Automatic and Grinnell were the first two to go through.
It's some old names.
To go through the first program with Factory Mutual, but they actually started with a K11 upright.
Oh, really?
For the first prototype of an ESFR.
So it's an upright. It was an upright ESFR. They
had the large drop, and they knew that performance. They knew that was better than a K8. But when they wanted a better sprinkler, they were playing around with a large drop with a faster response. And they were mixing around and eventually landed in pendant because they were asking for prototypes from the manufacturers. So if you go through the letters when they're asking for prototypes for their new research, it started with a K11 upright. Central Sprinkler had a K11 D64. That was a result of the prototype that they had produced for Factory Mutual. And that was the first ELO sprinkler that was accepted to be a design density sprinkler for 231, 231C.
All right.
They never got rid of it. They kept that a K11 upright. Well, Factory Mutual, through iterations, ended up with a K14 pendant. That's what they introduced in 1986. Automatic had the first approval for 30-foot ceilings.
Oh, boy.
And this was pushing the boundaries.
Back then.
The large drop was sitting around 20 to 25 feet, and the ESFR now went to 30 feet. Well, what happens in this industry? You launch 30 feet, immediately people needed 32. Because 30 feet on the edge of a building had a slope roof. They needed 32 at the peak. Can you give me 32? Just all I need is 2 more feet. It's a great industry, but as soon as you
give them something, they've got something else.
A little bit higher.
Some things haven't changed there either.
So they developed this K14, and then Factory Mutual immediately went to the 40-foot approval. Grinnell was the first one to get the 40-foot. So the Automatic dropped off.
Okay.
They didn't pass the 40-foot test.
Mhm.
The Grinnell did, so they introduced the first ESFR with the K14.
Okay.
That existed from 1986, 1987, up until 90, 92, 93,
Mhm.
when, again, the research was pushed,
Mhm.
and that was done by the metal building manufacturers.
Okay.
They wanted a 45-foot building, because everyone needs just a
Sure,
little bit
just a
higher.
little bit more.
And the reason metal building needed a higher, metal buildings don't have the ability to have a roof drain in the middle of the roof.
Right. Okay.
So they had to have a slope
A
that
slope.
went from the center out, so they had a higher peak.
Mhm.
And they weren't competing with the wood frame construction
Okay.
that allowed for roof drains where they could slope the roof, the construction, and not go above 40 feet.
40 feet.
But so the metal building people wanted a higher roof structure. So what do? You take a K14
Mhm.
ESFR and you put some more pressure behind it. Because it's logical.
Sure.
If 0.1 density is good, then, excuse me, if 1.0 density is good, then 1.2 must be better and we can go higher.
Mhm.
Was not the case. As we tried to push more water through a K14, the performance got worse.
Right.
To our surprise.
Right.
And, because you fail, if you're not doing research, if you're not failing, you're not doing research. So we failed our first test for the metal building manufacturers at 45 feet. I think we were at 90 PSI, and the next test we went to 100 PSI. Because more must be better.
Yeah.
Yeah.
But it was.
Same with my English. More must be
More
better.
must be better.
And, it got worse.
Mhm.
Because the droplet size, as you're pushing all that water out, we were breaking apart the droplet
Collapsing
size.
your spray penetrator. Yeah.
And when it collapsed and produced small drops, it didn't penetrate the fire plume.
Mhm.
And these were getting taller
Big
buildings.
fires.
So the fire protection was getting worse. Then you have the aha moment that you have to, like the large drop to the K8, you need a bigger orifice size to produce the volume of water necessary for the challenge.
Sure.
So we immediately went to the K25 and started from scratch on the sprinkler.
Mhm.
What rules are there? There was no
Yeah,
K25.
Right.
The only K25s during that time were from the 1930s, and they used them in elevators.
Oh, jeez.
So there was no standard spray or spray sprinkler. There were very special nozzles that
Yep.
were done before, but nothing with a fast response and all the technology. So we found ourselves going to 45 feet, and they're pretty special to be able to do that.
Yep.
With the technology. But 10 years earlier, we couldn't use anything bigger than the K8.
Mhm.
And
Yeah.
today everyone's recognizing the droplet size and the characteristics of these
Mhm.
bigger orifice sizes, but they weren't understood.
Mhm.
You truly got to go burn it,
Right.
see how they operate, go
Mhm.
through the pressure ranges. They have a bunch of enhanced benefits with the bigger K factors.
Yeah.
As we've gone through.
Mhm.
But if the new technology equivalency wasn't there, you're really hard pressed to find a manufacturer that would spend the money to
Sure.
go wait 9 years for their technology to be accepted. So this new technology, bringing it back to that,
Mhm.
is the reason that the manufacturers can go out there and spend $1 million to do full-scale fire testing of storage configurations.
Yeah.
Because they can use it under the equivalency while NFPA is reviewing it.
Right. But it's a great way to put it. So there's your large drop to the K28 there, and we're going to spend a little bit of time with the K28 because that's our big K, and it's gone through all that testing, and it's gone through its approach to the standard and its approvals with FM. So I want to kind of touch on a little bit about this, how we're living with that equivalency provision even now. So we'll start off with one of my favorite videos because this is just really a great video. It's our VK514 K28 test, 55-foot ceiling, 45-foot storage. And again, you can walk us through this, but it's just the ignition. It's just a single test under a single sprinkler. I mean, it's one of the tests under a single sprinkler.
You can see from the height of storage, there's no in-rack sprinklers in here. This is just ceiling only protection. You're counting on that sprinkler to activate quickly and then quickly suppress that fire before it jumps an aisle.
Yep, I love the angle here down the flue space.
Yeah, this is the beauty of full-scale fire testing. It's year of planning and 30 seconds of panic.
You panic. You got to be sweating bullets
Yeah.
at this point right now.
Yeah. It's burning a Ferrari every time.
Yeah. So, I mean, pretty impressive right down through fire contained at 3:30. And so where did we, we've talked about this before. I mean, we had an entire Tech Talks on this particular item. But one of the things that we didn't talk about at that time because we were in the middle actually of submitting it to 13 at the time. So we didn't have any reason to kind of go down the equivalency provision. We thought, here's our data. We'll go in. They'll give us this new recognition because it was different. We literally broke the 12 sprinkler design criteria with this. And yeah, so we broke that barrier the same way standard spray broke a barrier, the same way extended coverage did, quick response did, residential did, large drop. I mean, we just broke another barrier here. And we got it recognized into FM 8-9 and let's talk just a little bit, just to go to review for anybody that didn't watch that Tech Talks, you can go back and watch it again. But just a quick review as to where we got here, or what we're looking at with this.
So let's go back in time and say we started with a K28 for the first ESFR.
Oh, okay.
It would be a 9-head design.
Yeah.
It would be a 9-head design in NFPA 13, but we didn't start with a K28.
Right.
We didn't start with a K25 or a K22. We started with a K14, which in today's standard, like starting with a 1/2-inch head.
Yeah. Okay.
For the occupancy. So the K14 under its 75 PSI and its 40-foot limitations and all the limitations that it had, developed a 12 sprinkler design, hydraulic design protocol.
Okay.
And it became ingrained. It's like 1,500 square feet for light hazard for your design area.
Sure.
It's just the number. It doesn't mean that all sprinklers and all technologies need 1,500. It's just the number that we say we're not comfortable with anything but that.
Right.
Well, this 12 sprinkler has just carried forward, but didn't get modified due to the technologies that were coming out. And as manufacturers, if you know 12 sprinklers is your protocol, you can lower your pressures, you can lower your design because you can open up as many as 8, 9 sprinklers sometimes, and still get a 12 sprinkler design. So you can play games with your pressure, you can play games with your obstructions, you can play games with a lot of things on your spacing with the 12 sprinkler design. Now, under the FM guidelines and in the FM approval, they are very specific to their obstructions. They're very specific to the location of the sprinklers relative to beams and pockets. So their installation rules and their fire testing that you can see gives us a 9-head design. And they're very confident that with their installation rules, with their hydraulic design criteria, that a 9-head design is appropriate. Now, when we submitted that to NFPA 13, what we missed was all of the obstruction rules, all of the sprinkler location rules and beam pocket rules and everything else haven't been updated as much as they have in FM.
Oh, okay.
Because much of the FM data is proprietary to FM. So they're insuring these buildings.
Right.
So they're going out and they're working with their clients and they're doing testing and they're finding out all these design variables that may or may not find its way into NFPA 13.
Okay.
So when NFPA 13 saw the 9-head design protocol, it's sort of, we're not comfortable with this. We like 12. Well, you'd feel very comfortable with 12 if your standard was written around it. Well, the FM standard is.
Yeah.
And that's why the FM standard, not only equivalent, but more up to date, more relevant to this current storage configurations that we're protecting. And that's why we say use the FM 8-9 and 2.0 under the equivalency section of NFPA 13.
Right.
Because it's designed for it. Within 13, because of the rules, and they apply from the 14 through the 28 universally. Right. And they're not all the same sprinkler. So there's some gaps there, and I hope 13 gets it corrected. I hope they correct it soon because the storage is changing so fast that if they don't, they'll be 20 years behind, like the area density curves that recently changed after 20 years of debate. So we finally got the area density out of 13, and it's going to take some time to get it cleaned up through the NFPA 13 installation standard, the installation technical committee, but also the discharge committee needs to work in conjunction to get these things separated.
Right. So in the meantime, we'll circle back now to applying this, because literally, we've been running a number of seminars here in Learning Center, and every now and again we get the AHJs in, and they're a little concerned about this. Well, why did you pull it? Why did you put it there, and why did you pull it back from? What was your reasoning for you had it there, and then with a NIPMAM, or you supported a NIPMAM to take your technology completely out of 13? Why would we do that? Why couldn't you do that? And kind of answer, because we don't want 12.
The economic benefit of the 9 sprinkler design of a 3x3, you can do 2-inch branch lines versus the 2.5.
Yeah.
The end user gets a more economical installation. The end user also gets a better fire protection system with the K28 than they would with a 14 or a 17 or something like that.
Sure.
Even the 22 and the 25, I say the 28 stands hands down as better fire protection. So knowing that the NFPA was going to label it as a standard ESFR and put it in the 12 sprinkler camp, it's better that you don't address it at all.
Right.
And we'll use the equivalency section. We'll let the end users take advantage of the economics of it and get the benefit of the insurability of better fire protection.
Yeah, and that's why we revisit this now, and now that we will revisit new technology. The language hasn't changed. It just got moved into this section called new technology, and actually going back to with the equivalency provision. And usually when I'm talking to an AHJ or we're talking to an engineer, or even one of our customers that's saying, look, I'm having trouble moving this guy off the needle. How can I help my AHJ to kind of understand and accept what's going on here? Because they know 13. If they know 13, that's great. Most of them have no idea about what an FM, what FM 8-9 even is. So I tend to try to focus them on, look, as long as this component of the equivalency provision is the technical documentation part. Do we have the technical documentation to back up the equivalency statement that we're making? We're saying it's equivalent.
Yes.
Do we have that equivalency documentation to back it up? We do. Now, this is not that's a fictitious little letterhead up on top, but it's what it is. You get it from.
The full scale report is the most important. And I want to explain the difference between, I think it's chapter 25 or 26, I forget, on the reorganization of them. There's a method to submit documentation into NFPA 13.
Oh, yeah.
That's not the new technology criteria.
Right.
The new technology criteria for an example on this one is the FM approval, the report, and the fire test data and the videos or whatever they need to see that it has gone through the testing for the application.
Right.
And that's the equivalency. There's a section in the back that says, if you want to change the standard, you're going to do other testing. So it's giving guidance to people.
Right.
What we had as a committee, I chaired storage for 16 years, long ago. But we had people bringing in one test.
Yeah.
And they would say, here's my test, now change your standard. Well, you haven't dealt with clearance. You haven't dealt with 4 or 5 things. So we wanted to give guidance to people, bringing information into 13. This FM approval is plenty of information to bring into NFPA 13 for change, but they wanted to put it into a cubbyhole. And I didn't want it in the cubbyhole. We didn't want it in the
certainly
cubbyhole.
did, yeah.
So we're going to stick with equivalency until we can go through a proper submittal with NFPA 13 and get them up to speed on whatever installation practices need to be resolved. Even if they have to split the criteria for ceiling heights and say, below 40 feet, we can accept all these, and above 40 feet, we have to have this sort of installation. I don't know where the final answer will be, but the FM approval gives the equivalency to 13, and you follow the FM guidelines on the design and install.
Yeah.
So we have plenty of information that shows the equivalency, and this is the same information that I had when I did ELO. So
Right.
back
Right.
when Central Sprinkler, Steve Meyer and the whole clan that we were together, when we made the K11 ELO equivalent to a K8.
Mm-hmm. Oh,
All I had was a FM test report.
Mm-hmm.
I had a bunch of videos and a lot of hotel nights spending, talking to contractors and talking to engineering firms
Mhm.
to tell them, while the standard said no
Right.
orifice size other than
Right.
K8 for the area density curves.
Mhm.
And all I had was this FM report and the same
Yeah.
thing under the equivalency. And we got the ELO
Yeah.
adopted and now is almost bread and butter. In fact, the criteria says you have to start with an ELO above a 0.35 density.
No, there you go. Yeah. You got
Pretty
it
cool
right in there.
stuff.
Yeah. Well, and we're not spending as many, in the 21st century now, we don't spend as many hotel nights, but I'll tell you right now, we're spending a lot of time.
Well, you don't.
Yeah, well, no,
Right.
that's right. See, you're going somewhere else here today. But no, we're doing the same thing. There's considerable of effort, reaching out to AHJs, through our educational processes and through, meetings with engineers, meetings with
Society-
contractors,
Society of Fire
SFPE,
Protection
right?
Engineers, Fire Marshals Associations. You know, you get this information out. It's how all this stuff develops.
Mhm.
NFPA 13 will come around.
Yeah.
They get there. But even when they do get there, it's going to be 8 to
Right.
10 years before it's adopted into a state law.
Mhm.
So we got to have that equivalency. We got to have these test reports. And I guarantee you, the automated storage rack industry
Oh, geez,
isn't waiting 8 to 10 years
No,
to figure out what
yeah.
their next rack is
That's-
going to be.
my goodness. And that's a bigger challenge even than
Right.
what we've got right
And we
now.
need these types of sprinklers. We need these, these big horses to
Yep.
go in there. And we're fighting a different challenge today than we did. We don't have, a lot of our controls are based on a 30-minute window.
Mhm.
That we provide control for 30 minutes so the fire department can establish control and do the mop-up operation.
Mhm.
It's different today. The access, the
Yeah.
aisle widths,
Yeah,
getting the fire department in there.
right.
uh,
What aisle widths? Yeah, it's on some of those.
Being able to see the fire, in a
Right.
50-foot high building. It's different today. So we need the best technologies that we have for that challenge because it's changing.
Yeah.
And it will change faster than what we can get adopted.
And one of the last time, this is where we just don't want to leave these guys hanging, is ultimately the approval is by the AHJ. I mean, we need to submit all this. The AHJ needs to be comfortable with it.
They need something in their file to say,
Right.
this was the reason I
This was the
accepted this
reason I accepted it.
technology. And the certifiability or the credibility of FM
Mhm.
is a pretty good one for storage.
Yeah, yeah.
Even though they developed the residential sprinkler a long
Mhm.
time ago,
Yeah.
they still take credit for that one. It's okay. But they're sort of the grandfather of it. And I can't think of a more credible agency right now to certify any SFR application.
Great. Okay. So, that does it for this walkthrough. If you need more information, we're here for you for more information, Viking Training, Viking Tech Services, or connect with us online. James, thanks a lot for walking us through a little bit of a history lesson, a big bit of a history lesson. I always enjoyed that, almost as much as I enjoy having you down the pub.
Well, Rolf would be proud,
Good.
God rest his soul, and Chet the same, God rest his soul. Two great mentors that they really opened my eyes about the application of standards and technologies getting into the standard.
Yep.
And where some of these things came from
Mhm.
and where they are today are amazing.
Yeah.
Amazing.
They set the things in motion, and we've
They did.
we've
They did.
lived under their vision.
They were right 50% of the time, so it's cool.
Great. All right. Thanks for your time.
Thank you.
Everybody,
Thank you.
that's it for us on Tech Talks. Keep an eye out for our next one in June. We'll be sending out information on that. So thanks for joining us.
And the last thing, just if anyone has any questions on the equivalency, they can contact us. We can help them through the
Absolutely.
process.
Absolutely. Don't want to forget
Whether you're
that.
an HJ, whether you're insurance, engineering firm, we do this for a living. So please contact us if we can help.
We'll go back to this. Make sure that you contact Tech Services or training or anybody like that here at Viking, and we'll be able to help you out.
Perfect.
All
Thanks,
right.
Jim.
Now we're going to the pub.
All
Thanks.
right.